Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 24 word problems involving geometry, and as it happens, these questions should prepare you for the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, the Pre-Screening Internet Delivered Computer Adaptive Test, that is the PiCAT, the Air Force Officer Qualification Test, that is the AFOQT, and the Officer Aptitude Rating, that is the OAR. Let me stress this. In order to get the most out of this video, you should pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As for your performance on this practice test, I want to mention this. If you get an 80% or better, that's considered outstanding. If you get a 70 to 79%, that's also considered very good, and chances are you're ready to take this test. If, however, you score 60 to 69%, that's considered average, and you may want to spend a week or two studying. And finally, if you score a 59 or below, that means you need to make some significant improvements, which means you should probably devote about a month or two studying for this test. And since everyone is studying to take one of these tests, I just want to mention that you can download a copy of my free reference sheet from my website. It's 18 pages long, and it includes all the formulas you need to answer all these word problems in today's video. And as you can see, these word problems are going to be broken down into various sections. There are going to be 6 questions about perimeter and area of quadrilaterals. There are going to be 7 questions about circles, 4 questions about triangles, and 7 questions about surface area and volume. Finally, I want to say this. Typically, after I post a video like this, I notice that quite a few of these paid tutors will start going through my videos and creating almost identical content. In light of the fact that that's happening, I don't encourage you to pay for tutoring whatsoever. This video has almost everything you need to know about geometry to be successful on any of these standardized tests. So with all that being said, let's go ahead and get started with today's video. All right, so this first question says, if a parallelogram has a height of x plus 2 and a base of x plus 6, then what is its area? Well, we should know that to find the area of a parallelogram, we simply multiply our base by our height. And as it happens, we were given both of those things. We were told the height of this parallelogram is x plus 2. Similarly, we were told that its base was x plus 6. So let's plug those values into our formula accordingly. This becomes area equals, again, base was x plus 6, so this becomes x plus 6 times x plus 2, which was our height. All right, so one of the challenging aspects of the ASVAB is it will take a lot of simple principles and combine them into one problem. So in this case, to start, we had to know how to find the area of a parallelogram, but now we actually have to know how to apply the distributive property to multiply these two polynomials together. And what we're going to do in this case is we're going to take this x, we're going to multiply it by this term as well as this term. Then we're going to take this 6, according to the distributive property. We're going to multiply it by this term and then this term. So let's go ahead and work on doing that. As you can see, to start, we have x times x, which is going to be x squared. Then we have x times 2, which is 2x. Then we have x times 6, which is 6x. And then we have 6 times 2, which is 12. Of course, we can combine like terms now. Notably, we can combine 2x and 6x to be 8x. All right, so to answer this question, the area of this parallelogram that has a height of x plus 2 and a base of x plus 6 is x squared plus 8x plus 12. All right, again, we had to use our knowledge of how to find the area of a parallelogram, as well as our ability to multiply polynomials together in order to solve this one. All right, so that's a very good practice problem there. All right, so number 2 says, if the perimeter of a square is 64 feet, then what is its area? All right, so we know we're working with a square, but this problem's challenging because it's saying something. It's saying, if I give you the perimeter of this square, there must be a way for you to find its area. So that is the crux of this problem. Let's see how we're going to do that. When problems get slightly more challenging, I always like to sketch things out. So in this case, I'm going to start by making a square here. In fact, I'm going to make 2 squares. But to start, I'm just going to make 1 here. And again, one of the properties I mentioned about squares is that they all have equal sides. So this side's equal to this side's equal to that side, and that side's equal to that side. How would I find the perimeter of this square? Well, again, if you recall from when we reviewed the formulas, our unknown side here we labeled S. And if that side's S, this side's S, this side's S, and this side's S, to find the perimeter of any quadrilateral, we just add up all the sides. So we're going to go perimeter of this square, for the time being, is going to be S plus S plus S plus S. That said, this problem told us what P is. It says the perimeter of this square is 64 feet. In other words, we know what P is. So instead of having P here, we can actually plug in 64. So this becomes 64 equals S plus S plus S plus S. And let's combine these S's to be one term. So this is 64 equals S plus S is 2S, plus S is 3S, plus S is 4S. All right. Now let's divide both sides by 4 to get S by itself. And again, S will tell us how long each of these sides is. So let's divide both sides by 4 next. This crosses out, leaving you with S on this side. 64 divided by 4. If you can't do that in your head, you're going to have to do it off to the side. And you're going to have to do long division. So this is 64 divided by 4. All right. And we start by asking ourselves, how many times does 4 go into 6 without going over? That's going to be 1 time. Given that 1 times 4 is 4. 6 minus 4 is 2. And now we drop down this 4. Now the question is, how many times does 4 go into 24 without going over? That's going to be 6 times. 4 times 6, you should know, is 24. So there's no remainder. So S is 16 in this case. And in math, we actually write the variable on the left. So this is S equals 16. Well, you might be saying to yourself, how is that going to help me find the area of this square? Well, let's go ahead and make another square if it's helpful. Again, we now know that this square has side lengths of 16. All right, and how do you find the area of a square? Again, it's always S times S, and we know what those sides are. It's 16 by 16, so this becomes 16 times 16. And if you don't want to make a mistake by doing this mental math wrong, you can go ahead and do the multiplication off to the side. 6 times 6 is 36. So we drop down to 6 and carry a 3. 1 times 6 is 6 plus 3 is 9. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 6 is 6. 1 times 1 is 1. Let's add these together now. 6 plus 0 is 6. 9 plus 6 is going to be 15, so drop down to 5 and carry a 1. 1 plus 1 is 2. So the area of this square is going to be 256 feet squared. And that is the answer to this one. Again, for the ASVAB, and as far as squares go, you have to realize that perimeter and area occupy a two-way street. That is to say, if I give you the perimeter of a square, you should be able to find its area. Likewise, if I give you the area of a square, you should also be able to find its perimeter. Again, those occupy a two-way street. All right, so that's a good example of that one. All right, so number 3 here says the perimeter of a rectangle is 38 inches. If the length of a rectangle is 3 inches more than its width, what is the width of the rectangle? All right, so we're working with a rectangle, and this problem seems somewhat challenging at first. So first thing I'm going to do is quickly sketch a rectangle here. And again, we should know some properties of rectangles, notably that this width is equal to this width, and this length is equal to this length. Additionally, we were told that this rectangle had a perimeter of 38 inches. So I'm going to say P equals 38. What's more, we were told that the length of the rectangle is 3 more inches than its width. Okay, so we don't know how wide it is. So I'm going to call it X inches wide. And if its length is 3 more inches than its width, that means its length is X plus 3. All right. Likewise, we know if this width is X, this side's also going to be X. And if this length is X plus 3, that means this length is going to be X plus 3. All right. How do we find the perimeter of a rectangle? We just add up all of its sides. So I'm going to add this X plus 3, this X, and this X plus 3 together. So that's going to look like this. X plus 3 plus X plus X plus 3. And if it's helpful, you can see that this is the width, this is one of the lengths, this is another width, and this is another length. All right. So let's go ahead and add these together. Let's combine all of our x's. We have x, 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 and x. We have 4 x's. And then we have 3 and 3. So we just have plus 6. Again, we were told what P is. P is 38. So in place of P here, I'm going to put 38. This becomes 38 equals 4x plus 6. All right. And we should see that if we solve for x, we'll know the width of this rectangle. Because here, look, x is the width of this rectangle. So our goal here is to solve for x. Let's start by subtracting 6 from both sides. This crosses out here. 38 minus 6 is going to be 32. So this is 32 equals 4x. Let's divide both sides by 4 now to get x by itself. This crosses out, leaving you with x equals 32 divided by 4 is 8. So x equals 8 in this case. In other words, the width of this rectangle is 8 inches. Again, x corresponds to the width of this rectangle. So x is 8. We know its width is 8. All right, so the challenging part of this problem was you had to use some basic algebra as well as your knowledge of how to find the perimeter of a quadrilateral, notably a rectangle, in order to solve this one. So again, you should see a pattern. We're combining 2 basic concepts into one, some basic algebra and some basic knowledge of geometry. And that's what makes the ASVAB difficult. All right, so let's go ahead and move on to the 4th question now. All right, so number 4 here says, how many feet of a wire fence is necessary to enclose a garden that is square and has an area of 225 square feet? All right, so while it may not be obvious at first glance, this is a problem testing your understanding of the relationship between the area and perimeter of squares. And as I said previously, perimeter and area live on a two-way street. That is to say, if you're given the perimeter of a square, you can find its area. Likewise, if you're given the area of a square, you can find its perimeter. So in a previous problem, we went from perimeter to area. In this problem, we're going to be going from area back down to perimeter. So let's see what that looks like. All right, first things first, I'm going to start this one by making a quick sketch. And we know we're working with the square in this case, so let's quickly make one of those as best we can here. And one of the properties of squares that we should know is that all the sides are equal. This side's equal to this side, that side's equal to that side, and that side's equal to that side. You may recall that if we don't know how long these sides are, we can call them S. And if that side's S, this side's S, this side's S, and this side's S. All right, so let's start with finding the area of this square. We know what its area is. According to the problem, this square has an area of 225 square feet. And I'm going to drop off that square feet since we're just doing some math here. How do you find the area of a square? Remember, area of a square is S times S, which is the same thing as S squared. Again, S times S is S squared. Well, we know what our area is according to the problem. It's 225. So in place of A here, I'm going to plug in 225. This becomes 225 equals S squared. And now we should see that if I solve for S, I'll know how long the sides of this square is. All right. So in order to solve for S, we're actually going to have to take the square root of both sides here. This will cross out this square here, leaving you with just S on this side. What is the square root of 225? You should know this one. It's going to be 15. So S in this case is 15. All right. Again, on my formula sheet on my website, I have a list of perfect squares that you should memorize 1 through 20. And you should know that the square root of 225 is going to be 15. All right. So now we know we're working with a square garden that has sides that measure 15, 15, 15, and 15. And the question is, how many feet of wire fence is necessary to enclose this garden? Well, from here to here, this section of the fence is 15 feet. From here to here is 15 feet. From here to here is 15 feet. And from here to here is 15 feet. In other words, in order to find out how much feet we need to enclose this garden, we're going to be finding the perimeter of this garden, which is S plus S plus S plus S. And we know what all those values are. They're 15 plus 15 plus 15 plus 15. And you should be able to do this one mentally. We have 15 and 15 and 15 and 15. This is 30 plus 30, which is 60. So you're going to need 60 feet of wire fence to enclose a garden that has an area of 225 square feet. Again, you have to understand that for squares at least, if you're given the perimeter, you can find the area. If you're given the area, you can find the perimeter. All right, so that's that one. All right, so number 5 says, what is the length of the diagonal of a rectangle that has a length of 12 inches and a width of 5 inches? So for this problem, we know we're working with a rectangle. So let's quickly sketch one of those. And we should know some properties of rectangles. Notably, this width is equal to this width, and this length is going to be equal to this length. And we're told what those values are. We're told that this rectangle has a length of 12. So this is 12, and this is also 12, and a width of 5. So this is 5, and this is 5. What's more, the problem's asking us to find the length of the diagonal of our rectangle. Well, what is the diagonal of our rectangle? It's the distance from here to here. That is, we're slicing this rectangle in half. And when we slice a rectangle in half, we get 2 right triangles. All right. So the question is, how can we use this information about these right triangles to find the length of this diagonal? Well, let's pull one of those right triangles out. So I'm going to draw one of these right triangles off to the side here. Again, this is 12 here, and this is 5 here. Here's our right angle. And we should know something about right triangles that's going to help us do this. Well, according to the Pythagorean theorem, if you're given legs of a right triangle, you can always find the length of its hypotenuse. And how do you identify its hypotenuse? Its hypotenuse is always directly across from its right angle. So this length right here is our hypotenuse, and we can find it using the Pythagorean theorem. And as you can see, this length is this diagonal. So if we find the hypotenuse of this right triangle, we'll know the length of this diagonal. All right, so again, the Pythagorean theorem says a squared plus b squared is equal to c squared, where a and b refer to the legs of your right triangle, and c refers to your hypotenuse. So a is going to be 12, b is going to be 5, and c is going to be the length of our hypotenuse. Let's go ahead and plug those values in accordingly. This becomes 12 squared plus 5 squared equals c squared. We should know that 12 squared is going to be 144. 5 squared is 25. Of course, this equals c squared. Let's add these together. And so as not to make any mistakes, let's go ahead and add these together off to the side. We have 144 plus 25. 4 plus 5 is 9. 4 plus 2 is 6. And 1 plus nothing is 1. So this becomes 169 equals c squared. Again, we just want to know c, not c squared. So to get c by itself, we're going to take the square root of both sides. This crosses out here, leaving you with just c on this side. What is the square root of 169? It's on my reference sheet. You should be able to find it. It's going to be 13. So c in this case is 13. That means the length of our hypotenuse here is 13. Likewise, that tells us the length of our diagonal here is 13. So to answer this question, the length of our diagonal is going to be 13 inches. All right, so again, I kind of threw this one in here because sometimes your knowledge of rectangles is going to be combined with your knowledge of the Pythagorean Theorem, which I've discussed in other videos. So again, the ASVAB likes to take two simple concepts and combine them into one problem to make one challenging problem. And you've seen that for all the practice problems in this video. All right, so that's that one. Let's go ahead and move on to the final problem in this video. All right, so number 6 says, if the ratio of the side length of square A to the side length of square B is 1 to 2, what is the ratio of their perimeters? All right, so for this one, it should be pretty obvious that we're comparing two squares. We have one little square, which I'm going to draw right here. And I'm going to call this, let me fix that bottom part real quick. I'm going to call this square A. And we're comparing that to a bigger square called square B, which I'm going to draw over here. This is square B. Again, the same properties about squares still apply. This side's equal to this side, that side's equal to that side, and that side's equal to that side. Likewise, all these sides are equal to. We're told that the side length of square A to the side length of square B is 1 to 2. So to me, that means that we can let this side be 1 inch and this side be 2 inches. Again, if I were to ask you what the ratio of the side length of square A to the side length of square B is, you would say it's 1 to 2. Again, 1 to 2. All right. And the question is this. Given this ratio of their side lengths, what is the ratio of their perimeters? So we're going to have to find the perimeter of square A as well as the perimeter of square B. And as it happens, that's pretty easy to do. Again, if this side's 1, this side's also going to be 1, this side's going to be 1, and this side's going to be 1. Likewise, this side's going to be 2, this side's going to be 2, and this side's going to be 2. Again, to find the perimeter of squares, we simply add up all their sides. So this is going to be 1 plus 1 plus 1 plus 1. And this is going to be 2 plus 2 plus 2 plus 2. All right. So this is 1 plus 1 plus 1 plus 1, which is 4. So the perimeter of square A is 4. And the perimeter of square B is 2, 4, 6, 8. All right. So what is the ratio of their perimeters? Again, it's 4 to 8. But that said, can't we reduce that? Isn't 4 and 8 both divisible? Aren't 4 and 8 both divisible by 4? Again, 4 divided by 4 is 1. 8 divided by 4 is 2. All right, so the ratio of their perimeters is either 4 to 8, which is the same as 1 to 2. In other words, the ratio of their side lengths is the same ratio as their perimeters. Again, their side lengths had a ratio of 1 to 2. And ultimately, their perimeters have a ratio of 1 to 2 as well. So number 1 says a rectangle has a length of 12 inches and a width of 5 inches. What is the diagonal of the rectangle? So you might be saying to yourself, how am I going to figure out what this is using my knowledge of triangles? Well, let's make a sketch here. First, let's sketch a rectangle since we know that's what we're dealing with. And you should know some properties of rectangles. Notably, this length of this rectangle is the same as this length, and this width of the rectangle is the same as this width. So according to the problem, this is 12, which means that this is 12. This is 5, which means that this is 5. And we want to know, what is the diagonal of the rectangle? Well, a diagonal of a rectangle basically means you cut it in half from here to here. And when you do that, what you get is a pair of right triangles. As a matter of fact, I could go ahead and pull one of those right triangles off to the side here. So we know this is 5 and this is 12. Well, here's our right angle. And we know that right across from our right angle is our hypotenuse, or C. In other words, if we figure out what C is here, we'll know the length of this diagonal in this rectangle. And how can we figure out what C is, the hypotenuse? Well, we can use the Pythagorean theorem. And the Pythagorean theorem says this: a squared plus b squared has to equal c squared, where a and b are the legs of the right triangle, and c is the hypotenuse of the right triangle. So we're going to be solving the Pythagorean theorem for c. We're going to let this be a and this be b. So this becomes 12 squared plus 5 squared equals c squared. 12 squared, of course, is the same as 12 times 12, which is 144. 5 squared is 5 times 5, which is 25, equals c squared. So as not to make any mistakes here, I'm going to add these off to the side. 144 plus 25. 4 plus 5 is 9. 4 plus 2 is going to be 6. And 1 plus nothing is 1. So this is 169 equals c squared. We want to get c by itself, not c squared. So we're going to take the square root of both sides. This will cross out this square here, leaving us with just c on this side. What is the square root of 169? It's on my reference sheet on my website. It's 13. So c in this case is 13. Since c is 13, we know the length of this diagonal is also 13 inches. All right, so the answer to this one is 13. All right, so number 2 here says, in a triangle, if the second angle is 2 times the first angle, and the third angle is 3 times the first angle, find the angles of the triangle. Well, we can use the Triangle Sum Theorem to figure this one out. Again, according to the Triangle Sum Theorem, angle 1 plus angle 2 plus angle 3 in a triangle are always going to add up to 180 degrees. And let's make a sketch in this case to try to figure out what's going on in number 2. So we have our triangle here. And it seems to me that both angle 2 and angle 3 reference angle 1. It says the second angle is 2 times the first angle, and the third angle is 3 times the first angle. And we don't know any of those values. So I'm going to let angle 1 be x. And let's go from there. If the second angle is 2 times the first angle, well, if the first angle is x, that means the second angle is 2x. Similarly, if the third angle is 3 times the first angle, that means that if the first angle is x, the third angle is going to be 3x. So here's angle 1, here's angle 2, here's angle 3. Now let's plug those values into the Triangle Sum Theorem here. This becomes x plus 2x plus 3x equals 180. All these are like terms, so we can combine them. X plus 2x is 3x. 3x plus 3x is going to be 6x equals 180. Now let's divide both sides by 6 to get x by itself. This crosses out here, leaving us with just x. And you should be able to do this in your head. How many times does 6 go into 18? Well, that's going to be 3 times, and then just drop down that 0. So in other words, 180 divided by 6 is 30. I'll do this the long way if you need to see it. This says 180 divided by 6. 6 doesn't go to 1. 6 goes into 18 3 times, but that said 6 goes into 180 30 times 6 is 180. 180 minus 180 is 0. All right. Now we had to find all the angles of this triangle, and we can see those are right here. Angle 1 is x, angle 2 is 2x, and angle 3 is 3x. So angle 1 is equal to x, and we know x is 30, so angle 1 is 30 degrees. Angle 2 is 2x, and we know x is 30, so this becomes 2 times 30, which is 60 degrees. And then finally, angle 3, we can see is 3x. We know x is now 30, so this becomes 3 times 30, which is 90 degrees. All right, so those are our angle measures, 30, 60, and 90. And that is that one. So number 3 says the base of a triangle is 6 inches more than its height. If the area of a triangle is 36 square inches, what is the height of the triangle? So it should be pretty clear that at some point we're going to have to use the area formula to figure this one out. And to find the area of a triangle, it's 1/2 base times height. So let's go ahead and just jot that down from the get-go. And this problem's a little bit challenging because you also have to think about this problem both visually as well as algebraically. So let's start by thinking about this problem visually. Visually, we're dealing with a triangle. And as it happens, I'm going to make a right triangle since I think those are pretty easy to deal with. Here's the height of my right triangle, and here's the base of my right triangle. That is, this side length is our height, and this side length is our base. Well, what's this problem say? It says the base of the triangle is 6 inches more than its height. So we don't know how high this triangle is, so it's going to be x inches high, and that means its base is going to be x plus 6 inches long. All right. So we've taken care of the visual part as well as the algebraic part. Let's go ahead and try to solve this one using this formula now. We're told, according to the problem, that the triangle has an area of 36 square inches. So we know A is 36 square inches. So this becomes 36 equals 1/2. What is our base? It's x plus 6. What is our height? Our height is x. All right, so clearly, if we solve for x here, we'll know the height of this triangle. That said, we got this pesky fraction hanging out in front here. So let's go ahead and clear that by multiplying both sides of this equation by 2. This will cross out here, and 2 times 1/2 is just 1. Anything times 1 is itself, so this goes away here. That said, we still have to work this out. 36 times 2. 6 times 2 is 12, carry a 1. 3 times 2 is 6, plus 1 is 7. So this becomes 72 equals x plus 6 times x. Let's go ahead and work this out using the distributive property. We got to take this x, we got to multiply it to this x, and then we have to multiply it to this 6. So this becomes x times x, which is x squared, plus 6 times x, which is 6x, equals 72. And at this point, you're probably saying to yourself, how am I going to solve this one for x when I have x squared, 6x, and 72? Well, if we subtract 72 from both sides, this crosses out here, leaving you with 0 on this side, x squared plus 6x minus 72. And let's go ahead and rewrite this such that the 0 is on this side. This becomes x squared plus 6x minus 72 equals 0. Well, as it happens, you should be able to factor this since this is a quadratic equation that has a leading coefficient of 1. More specifically, you should be able to factor this one like this. You should be able to go x times x. Now we have to figure out two numbers that multiply to negative 72 but add to positive 6. Well, I know that 12 times negative 6 is negative 72, and similarly 12 minus 6 is positive 6. All right, so here are our two factors. But that said, we're not done yet because we have to solve these for x, which means we're going to set them both equal to 0 like this. X plus 12 equals 0, and x minus 6 equals 0. When we solve for x here, we're going to subtract 12 from both sides. This crosses out, leaving you with x equals negative 12. And to solve for x here, we're going to add 6 to both sides. My pen's starting to die here. This crosses out here, leaving you with x equals 6. Well, let's think about this. We know that the height of our triangle is x. Do you think it can be a negative value? It can, so we know that's not correct. So we know x in this case is going to be 6. So x is 6. And of course, we can see that x corresponds to the height of this triangle. So that is that one. So number 4, as you can see, says, which of the following does not represent the sides of a triangle? Well, as you may recall, we can use the side lengths and the Triangle Inequality Theorem to determine if something is a triangle or not. Specifically, the Triangle Inequality Theorem says this. If we have a triangle, and let's go ahead and quickly draw a triangle, then the sum of two of its sides always has to be greater than the third side. So if I let this side be A, this side be B, and this side be C, that means this. A plus B has to be greater than C. Likewise, A plus C has to be greater than B. And finally, B plus C has to be greater than A. If we fail to meet any of these conditions, then we do not have a triangle. So let's go ahead and apply that theorem to each of our answer choices here. And let me say this. I know this theorem so well and the math so easy to do that just by looking at the answer choices, I can tell you which of these is not a triangle. But that said, let's work out one or two of these, and then I'll explain how I quickly determine which one's not a triangle. So let's start with A here, and I'm going to make a triangle since I think it will be helpful. Again, let's call this A, this B, and this C, and let's label these correspondingly. This is A, this is B, this is C. So this is 2, this is 6, and this is 7. And let's apply these tests. Again, A plus B has to be greater than C. So 2 plus 6 has to be greater than 7. 2 plus 6 is 8. Is 8 greater than 7? It is. All right, so we passed there. Next, let's move to A plus C. So that's going to be 2 plus 7. 2 plus 7 has to be greater than B, which is 6. 2 plus 7 is 9. Is 9 greater than 6? It is. And finally, let's move on to B plus C, and that has to be greater than A. B is 6. C is 7. That has to be greater than A, which is 2. 6 plus 7 is 13, so 13 has to be greater than 2. It is. So since these side lengths all passed the triangle inequality theorem, we know that A is in fact a triangle. All right, let's go ahead and move to D and test that one out. And if it's helpful, you can quickly make a triangle. And I'm going to call this A, B, and C. And let's label these accordingly. This is A, this is B, and this is C. So this is 3, 10, and 15. And let's start applying these tests here. Again, the first one is A plus B has to be greater than C. So 3 plus 10 has to be greater than 15. 3 plus 10 is 13. Is 13 greater than 15? It isn't. So this fails one of the conditions in the triangle inequality theorem, and therefore I know D is not a triangle. All right. And by the way, I knew that almost immediately because I said 3 plus 10 is less than 15. It fails to meet the conditions set out by the Triangle Inequality Theorem. So again, don't be afraid to use mental math to figure these out, as long as you know that the sum of two lengths has to be greater than the third length. So this first question says, using 22 over 7 to approximate pi, find the area of a circle that has a diameter of 4/5 of a centimeter. Express your answer as a fraction. All right, so first things first, we know we're going to be finding the area of this circle, and there's only one formula we can use to find the area of a circle. Notably, area is equal to pi r squared, where r, of course, refers to the radius of a circle. All right, we have a little bit of a problem here. According to this problem, we know the diameter of this circle is 4/5 of a centimeter. That said, to find the area of this circle, we don't need its diameter, we need its radius. So again, we're going to have to fall back on the relationship between diameter and radius of a circle. Notably, diameter is always twice as long as the radius. So in place of D here, I can go ahead and plug in 4/5. This becomes 4/5 equals 2r. If we solve for r, we'll know what our radius is. So we're going to divide both sides by 2 now. This will cross out over here, leaving you with just r on this side. But that said, we have this left, 4/5 divided by 2. One thing you can do is you can rewrite 2 as a fraction by placing it over 1. And now this says 4/5 divided by 2 over 1. And let me pull this off to the side. We have 4/5 divided by 2 over 1. That is to say, we're dividing two fractions now. Well, how are we going to proceed? When you divide two fractions, you follow the algorithm keep, change, flip. That means you keep this top fraction as is, so that's going to be 4/5. You change from division to multiplication. So we went from division to multiplication, that's our change. And then you flip this second fraction. So instead of being 2 over 1, it's going to be 1 over 2. All right, so now we're just multiplying 4/5 by 1/2. When you multiply fractions, you just multiply straight across. So 4 times 1 is 4. 5 times 2 is 10. This becomes 4/10. And we can reduce this very quickly. You should notice that both 4 and 10 are divisible by a common factor of 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So we know our radius in this case is going to be 2/5. All right, so now that we figured out what our radius is, we can go ahead and plug it into our formula over here. This becomes area equals pi, and radius is 2/5 squared. All right, so let's go ahead and work this out. 2/5 squared. How are we going to deal with that? Well, whenever you have a fraction squared like this, it becomes this. Okay, we have 2/5 squared. This square is going to be applied to each of these separately. So I like to think about this one like this. 2 squared over 5 squared. 2 squared is 4. 5 squared is 25. So this becomes pi times 4 over 25. Of course, we were told to use 22 over 7 to approximate pi. So we know pi is going to be 22 over 7 times 4 over 25. And now we're just multiplying two fractions again. So we're going to multiply straight across. That is to say, this is going to become 22 times 4 over 7 times 25. Let me go ahead and scroll down a little bit. If you can't do this mentally, you could always do it off to the side. 22 times 4. 2 times 4 is 8. 2 times 4 is 8. So this becomes 88 over, what is 7 times 25? Again, if you can't do that mentally, you can always work it off to the side like this. My pen's starting to act up on this one. 7 times 5 is 35, so bring down a 5, carry a 3. 7 times 2 is 14, 15, 16, 17. So this is 88 over 175. Of course, this is going to be centimeters squared. And the problem said leave your answer as a fraction. And I do not believe we can reduce this. So our answer to this one is its area is 88 over 175 centimeters squared. All right, so as you can see, I can quickly throw in a lot of simple things into a word problem to make it much more challenging than what we've seen so far. As a matter of fact, first I tested your knowledge of knowing the formula to find the area of a circle. After that, I tested your knowledge of the relationship between diameter and radius. In the middle of that, you had to know how to divide fractions and multiply fractions. Okay, so this is a very typical question that you may see on the ASVAB or PiCAT. You can't escape working with fractions. You have to know how to work with fractions. In addition, you have to memorize these formulas, and you also have to know the relationship between diameter and radius of a circle. So again, that's a very challenging problem, but it's representative of what may show up on the actual test. All right, so that's that one. All right, so number 2 says, if the area of a circle is 36 pi, then what is its radius? All right, so we know we're working with the area of a circle, so let's write down that formula. Area equals pi r squared. In this case, we were told that the area of this circle is 36 pi, and we want to figure out what its radius, or r, is. So in place of a, I'm going to go ahead and plug in 36 pi. This becomes 36 pi equals pi r squared. And again, we're trying to figure out what its radius, or r, is. So we're going to be solving for r in this case. So let's start by dividing both sides by pi. This crosses out here, leaving you at just r squared on this side. These two pi's cross out over here, leaving you at just 36 on this side. To get rid of this square, we're going to take the square root of both sides. This will cross out this square, leaving you at just r here. The square root of 36 is just 6, so we can see r in this case is 6. And we weren't given a unit, so we're just going to say the radius is 6. All right, so number 3 says the diameter of the wheel on a bus is 1 foot. How much distance will the bus cover in 100 rotations of the wheel? Use 3.14 for pi. All right, so for this problem, you have to understand that there is a relationship between the circumference of a circle and the distance a wheel travels on the ground. And let me go ahead and try to explain that for you. So let's say we had this circle here. Let me draw a better circle. Let's say we had this circle here. And let's imagine I tied a string around this circle so it's snug all the way around. Well, what if I cut that string and then laid it out flat on the ground, like so? What that would tell you is the circumference of the circle is the same distance that the wheel travels upon one rotation. Again, the circumference of a circle is the same distance that a wheel travels upon one rotation. And again, if it's helpful, think about tying a string around a circle, cutting that string, and then laying that string flat across the ground. All right, so for this one, we're going to start by finding the circumference of this wheel. We know this wheel has a diameter of 1 foot. And again, there are two formulas to find the circumference of a circle, notably 2 pi r, as well as pi times diameter. Since we were given diameter, we're going to use pi times diameter in this case. And of course, we're going to take 1 and plug it in for d. So this becomes circumference equals pi times 1. And of course, we were told to use 3.14 to approximate pi. So let's plug that in as well. Anything times 1 is itself. So 3.14 times 1 is 3.14. So we know that this bus wheel has a circumference of 3.14. That means that upon one rotation, it goes 3.14 feet across the ground. In order to figure out how much ground it covers upon 100 rotations, we're going to take 3.14 and we're going to multiply that by 100. All right. And this math, as it turns out, is very easy to do. As you can see, we're multiplying 3.14 by a power of 10, notably 100. As I mentioned in this video previously, when you multiply a decimal by a power of 10, such as 10, 100, 1000, 10,000, and so on, you just take that decimal and you shift it to the right according to how many zeros there are in your power of 10. Well, in 100, there are 2 zeros. So we're going to take 3.14, we're going to shift it 2 times to the right, and our decimal's right here. So this becomes 314. In other words, if this wheel on the bus that has a diameter of 1 foot is rotated 100 times, that means that the bus will have traveled a total distance of 314 feet. All right, so number 4 says the area of one circle is 4 times as large as a smaller circle. If the smaller circle has a radius of 3 inches, then what is the radius of the larger circle? So at first glance, this problem seems pretty challenging, and it is. That said, at the end of the day, we're just comparing 2 circles with each other. In addition, we know that this small circle has a radius of 3 inches, and we want to know what the radius of this large circle is. Again, this large circle has 4 times the area of this small circle. So the first thing I want to do is figure out what the area of this smaller circle is. And again, to find the area of a circle, it's pi r squared. We know the radius of this small circle is 3, so this becomes area equals pi 3 squared. 3 squared is 9, so the area of this small circle is 9 pi. Again, if the area of this small circle is 9 pi, that means that the area of this big circle is going to be 4 times 9 pi. What is 4 times 9? 4 times 9, of course, is 36. So the area of this big circle here is 36 pi. And we saw previously that if we know the area of a circle, we can find its radius. Again, the area of this big circle would be pi r squared. We know that this big circle has an area of 36 pi. So in place of a here, I'm going to put 36 pi equals pi r squared. Let's divide, as we did previously, both sides by pi now. This crosses out, leaving you with r squared over here. These cross out as well, leaving you with 36. To get rid of this square, we'll take the square root of both sides. This will cross out this square, leaving you with r on this side. The square root of 36 is 6, so r in this case is 6, and that's going to be inches. All right, so the radius of our larger circle, as you can see, is 6 inches. All right, so that's that one. Somewhat of a challenging problem, but you may have noticed that to solve these more challenging problems, we're using all the smaller pieces that we worked out from the easy problems. All right, so number 5, which is a question I got from one of my free practice tests on my website, says this: what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they're inscribed by a rectangle. Use 3.14 for pi. All right, so again, we're trying to figure out what the area of this shaded section below is. And it should be pretty obvious that to find the area of the shaded section, we're first going to find the area of our rectangle. And from that, we're going to subtract the area of one of these circles, and I'm going to call that area of circle 1, as well as the area of our other circle, which I'm going to call area of circle 2. Now, since these circles are identical, we can actually just write this like this. Area of our rectangle minus 2 times the area of circle 1. Again, circle 1 and circle 2 are identical, therefore their areas are the same. All right? Now, how do we find the area of a rectangle? Of course, that's length times width. And how do we find the area of a circle? We should know by now that that's pi r squared. All right? Again, according to the problem, we know what the radius of one of our circles is. It's right here. It's 5. So let's go ahead and plug that in. This becomes length times width minus 2 times pi 5 squared. Let's go ahead and work this out very quickly. This becomes length times width minus 2 times, what is 5 squared? 5 squared is 25, so this becomes 25 pi. And what is 2 times 25 pi? Well, that's going to be 50 pi. All right, so clearly we've worked this out as much as we can, and now we've hit a little bit of a roadblock insofar as we don't know what the length or width of this rectangle is. That said, using our knowledge of the definition of what a radius is, we can quickly figure out what L and W are. Again, as I said in this video, radius is defined as the distance from the center point of the circle to the edge of the circle. So from here to here is a radius. And according to the problem, we know this circle has a radius of 5. And from here to here is another radius. Again, according to the problem, we know that that is 5. Clearly, this is the same as the width of this rectangle. So we know width is going to be 5 plus 5 or 10. Again, using our definition of what a radius is, we can also find what the length of this rectangle is, because from here to here is a radius. We know that's 5. If we put our center point down, we know from here to here is 5, and from here to here is 5. So from here all the way to here is the same distance as the length of our rectangle. So that's going to be 5 plus 5, 10, plus 5, 15, plus 5, 20. All right, so this becomes 20 times 10 minus 50 pi. 20 times 10, that's 50 pi. 20 times 10 is going to be 200 minus 50 pi. Now we have to figure out what 50 pi is. Again, according to the problem, we're going to approximate pi with 3.14. So this becomes 200 minus 50 times 3.14. And I'm going to work that off to the side so as not to make any mistakes. We have 50 times 3.14. So what we want to do is take this decimal in 3.14 and shift it 2 times to the right, such that this becomes 314 times 50. And once we work this out, we're going to take our 2 decimals that we moved to the right here and shift them back into the left. So let's work this out. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with that 5, we have to bring in a 0 placeholder. 5 times 4 is 20, so bring down a 0 and carry a 2. 5 times 1 is 5, plus 2 is 7, and 5 times 3 is 15. Let's add these together. 0 plus 0 is 0. 0 plus 0 is 0. 7 plus 0 is 7. 5 plus nothing is 5. 1 plus nothing is 1. Let's bring our 2 decimals back in. 1, 2. So this becomes 200 minus 157. And if you can't do that in your head, let's go ahead and work that off to the side as well. We have 200 minus 157. 0 minus 7 we can't do, so we have to look to the left to borrow. Can't borrow from a 0, so we're going to have to borrow all the way from this 2. This is going to become 1. This will become 10. borrow one more time. This become 9, and this become 10. 10 minus 7 is 3. 9 minus 5 is 4. 1 minus 1 is nothing. So this is 43 inches squared. In other words, the area of the shaded section of this figure is 43 inches squared. All right, so that's a challenging problem. But that said, again, if you use your knowledge of some basic principles of circles as well as rectangles, this problem was pretty simple and straightforward. All right, so that is that one. All right, so number 6 here says the circumference of a bicycle wheel is 50.24 inches. What is its diameter? Use 3.14 for pi. All right, so again, we're given the circumference of this wheel, so we know we're going to be working with the circumference formula. We want to know what its diameter is. So of the two formulas to find the circumference of a circle, we're going to use pi times diameter. This problem told us what C was. It said circumference, or C, is 50/24. So in place of C in our formula here, I'm going to put 50/24. So this becomes 50/24 equals, what is pi? We're told to use 3.14 for pi, and that's times d for diameter. We're trying to solve for diameter. So what we want to do now is get d by itself by dividing both sides by 3.14. This will cross out over here, leaving you with just d on this side. And as you can see, d is 50/24 divided by 3.14. In other words, by doing 50.24 divided by 3.14, we'll know what the diameter of this bicycle wheel is. And in case you haven't worked with decimals in a long time, we can go ahead and write this first like this. This says 50/24 divided by 3.14. When you're dividing decimals like this, you can't have a decimal outside the division bracket. So what we have to do is we have to take this decimal in 3.14 and shift it 2 times to make 3.14 314. And at the same time, we're going to take this decimal inside the division bracket and shift it 2 times as well to make it 5,024. All right, so now that we cleared the decimal from outside the division bracket, we can go ahead and proceed as we normally would. We start by asking ourselves, how many times does 314 go into 5? It doesn't. How many times does 314 go into 50? It doesn't. How many times does 314 go into 502 without going over? Well, that's going to be 1 time. Again, if this was 300 times 2, that would be 600, which is too big. All right, so we know it's 1. 314 times 1 is 314. Let's go ahead and perform this subtraction now. 2 minus 4 we can't do, so we're going to have to borrow. We have a 0 here, so we can't borrow there. We're going to have to borrow from this 5. This will become 4. This will become 10. We're going to borrow one more time. This will become 9, and this will become 12. 12 minus 4 is 8. 9 minus 1 is 8. And 4 minus 3 is 1. Now, of course, we got to drop down this 4. And the question is this. How many times does 314 go into 1884 without going over? Well, let's use some estimation here. If this was 300 and this was 1800, I would say 300 times 6 would be 1800. So I'm going to say 314 is going to go into 1884 about 6 times. And before I write that 6 here, I'm going to work this off to the side to confirm it. We have 314. We're multiplying that by 6. 4 times 6 is 24, so drop down a 4, carry a 2. 1 times 6 is 6, plus 2 is 8. And 3 times 6 is 18. So 314 times 6 is 1884, and there's no remainder. So the diameter of this circle that has a circumference of 50, 24 is going to be 16. And in math, we write the variable for which we solved on the left. So this is going to be d equals 16 inches. All right, so again, in this video, you've had to work with decimals as well as fractions. There's no escaping that on the ASVAB. All right, so number 7 says a semicircle shaped rug has a diameter of 2 feet. What is the area of the rug? Use 3.14 for pi. All right, so in this video, I've discussed how to find the area of circles. And we know that's area equals pi r squared. In this case, we're working with a semicircle. And a semicircle is just a circle that's been cut right in half. And as you can imagine, to find the area of a semicircle, we're going to take the area of a circle, which is pi r squared, and we're going to multiply that by 1/2. So in other words, we're going to be finding the area of this half of this circle, for instance. What's more, we know that the diameter of our rug is 2 feet in this case. So from here to here is 2 feet. Well, as you can see, we need to know what the radius of our rug is in order to find its area. So we're going to fall back to this relationship. The diameter of a circle is always twice its radius. We know that the diameter of our semicircle is 2 feet. So that's 2 equals 2r. If we divide both sides by 2, we can get r by itself. This crosses out there, leaving you with r. 2 divided by 2 is 1. So the radius of our semicircle is 1. So now that we know what r is, we can go ahead and plug it in accordingly. This becomes 1/2. Again, pi is going to be 3.14. And this is going to be r of 1 squared. 1 squared is the same thing as 1 times 1, so that's just 1. So this becomes 1/2 equals, or 1/2 times 3.14. 1 squared is just 1. Again, anything times 1 is just itself, so 3.14 times 1 is just 3.14. So this becomes 1/2 times 3.14. All right, so there are two approaches you can take to solving this. I've worked with circles so much that I know the answer is going to be 1.57. Again, half of 3.14 is 1.57. That said, if I was working this out on my own, I would do this. I would know 1/2 is the decimal equivalent of 0.5. So this would be 0.5 times 3.14. And then I would work this off to the side like this. 3.14 times 0.5. And now we got to clear these decimals. I got to move the decimal place 2 times here and 1 time here. So in total, I moved the decimal place 3 times to make this 314 times 5. Once I work this out without decimals, I'm going to take my decimal place and move it 3 times to the left. All right, so 4 times 5 is 20. Carry a 2. 5 times 1 is 5 plus 2 is 7. And 3 times 5 is 15. Bring our 3 decimals back in. 1, 2, 3. So we can see that 0.5 times 3.14 is going to be 1.57. So the area of our semicircle is 1.57, and this is going to be feet squared. This first one says a rectangular prism has a length of 10 centimeters and a width of 5 centimeters. If the volume of the prism is 250 centimeters cubed, find the height. So of course, you have to know that to find the volume of a rectangular prism, it's length times width times height. And according to this problem, our rectangular prism has a length of 10, a width of 5, and an unknown height. So we don't know what its height is. In addition, we were told that its volume is 250 centimeters cubed. So let's plug those values in accordingly. Again, we were told that its volume is 250. So in place of V here, I'm going to put 250. We know it has a length of 10, so this is 10, a width of 5, and an unknown height. So we'll just leave that as H. And clearly, by solving this equation for H, we'll be able to answer this question. So let's go ahead and do that. 10 times 5 is going to be 50. So this is 50h equals 250. To get h by itself, we'll divide both sides by 50 now. This crosses out here, leaving you with h on this side. And this math is actually incredibly easy to do. You can cross out these corresponding zeros. What is 25 divided by 5? That's 5. So the height of our rectangular prism has to be 5 centimeters. All right, so that is that one. All right, so number 2 says at Jacksonville's airport, a fueling truck can fill a gas tank at the rate of 250 cubic inches per minute. If a rectangular gas tank is 20 inches long, 15 inches wide, and 10 inches tall, how long will it take the fueling truck to fill this tank? All right, so we're going to be finding the volume of our rectangular gas tank. And since it's a rectangular gas tank, we know it's going to be a rectangular prism. The volume of a rectangular prism is length times width times height. And thankfully enough, we were given all those things in this problem. We know our rectangular gas tank has a length of 20 inches, so L is 20, a width of 15, so W is 15, and a height of 10. So let's go ahead and plug those values in. This becomes 20 times 15 times 10. And you could do this one mentally if you wanted to. You could say 20 times 10 is 200, so that leaves us with 200 times 15. And at this point, I might work this off to the side to be 200 times 15. 0 times 5 is 0. 0 times 5 is 0. 5 times 2 is 10. Before you start multiplication with that 1, you want to bring in a 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. 2 times 1 is 2. So right here we have 1,000 plus 2,000, which is 3,000. All right, so the volume of our rectangular gas tank is 3,000 cubic inches. Now let's go back to the other part of this problem where it says the fueling truck can fill a gas tank at a rate of 250 cubic inches per minute. So to figure out how long it's going to take this truck to fill up our tank, we're going to take the volume of our tank, which is 3,000, and we're going to divide that by how much volume of gas this fueling truck puts into the tank per minute, which is going to be 250. All right. So let's cross out these corresponding zeros to make this math a little bit easier. And you should be able to do this mentally, but if you couldn't, you could always read this as 300 divided by 25. And when you do long division, you start by asking yourself this: how many times does 25 go into 3? Doesn't. How many times does 25 go into 30 without going over? Well, that's going to be 1 time. 25 times 1 is 25. 30 minus 25 is going to be 5. Drop down this 0. Now the question is, how many times does 25 go into 50 without going over? That's going to be 2 times. Given that 2 times 25 is 50. 50 minus 50 is 0. So 300 divided by 25 is 12. In other words, it takes 12 minutes for this fueling truck to fill up our rectangular gas tank. So that is that one. All right, so number 3 says Tim has a rectangular prism with a length of 10 centimeters, a width of 2 centimeters, and an unknown height. He needs to build another rectangular prism with a length of 5 centimeters and the same height as the original prism. The volume of the 2 prisms will be the same. Find the width in centimeters of the new prism. All right, so there's quite a bit going on in this problem, and let's take it step by step. First of all, let's talk about finding the volume of this first prism. So I'm going to call that volume of prism 1. Well, we know how to find the volume of rectangular prisms. That's length times width times height. And let's see what was given according to this problem. Has a rectangular prism with a length of 10, so we know L is 10, and a width of 2, so W is 2. Height is unknown. known according to the problem. So let's plug those values in. We have a length of 10, so this is 10, a width of 2, so that's 2, and the height is unknown, so we'll leave that as h. 10 times 2 is going to be 20, so this is 20h. The volume of our first prism is 20h. All right, and that's all we could get from that. And let's go ahead and take a look at the second part of this problem. He wants to build another rectangular prism. So we're going to be finding the volume of a second rectangular prism, which I'm going to call V2. And we know how to find the volume of rectangular prisms. It's length times width times height. With a length of 5, so L is 5, and the same height as the original prism, the volume of the two prisms will be the same. So let's try to express that mathematically. The volume of this first prism has to equal the volume of this second prism. Find the width in centimeters of the new prism. All right, so let's go ahead and fill this in. We know that the length of our new prism is 5. We're trying to figure out what its width is, and we're told that its height is the same as this height, so we're going to have to leave that as h for the time being. That said, we know the volumes of these two prisms are the same. So the volume of prism 1 was 20h. That means the volume of prism 2 is also going to be 20h. So in place of V2 here, I can go ahead and plug in 20h. So this becomes 20h equals 5 times width times height. And it should be pretty clear now that we're going to be solving for W. And if we divide both sides by 5h, let's see what happens. Well, this h crosses out here, and these 5's cross out here, leaving you with W on this side. These h's cross out here, and 20 divided by 5 is 4. So the width of the second rectangular prism is going to be 4 centimeters. All right, so that is that one. Pretty challenging, but that said, if you understand how to find the volume of a rectangular prism, and you follow the instructions in the word problem, it's not that difficult at the end of the day. All right, so number 4 says you are asked to paint the ceiling and walls of a room. The room is 10 feet wide, 15 feet long, and 10 feet high. Calculate the surface area so that you can determine the gallons of paint needed. If a gallon of paint covers 175 square feet, how many gallons do you need to paint the room? All right, so clearly we're going to be finding surface area of this room. So to find the surface area of a rectangular prism, you may recall that surface area equals 2 length times width plus 2 width times height plus 2 height times length. And again, each of these is the area of the 6 faces of our rectangular prism. Now, let me go ahead and take a rectangular prism and unfold it for you, because we're going to have to pay close attention to the wording of this problem to get it correctly. So here is our floor of our rectangular prism. That means that this is the back wall. This is our front wall. This is our side wall. This is our side wall. And this is our ceiling. All right. So remember, we're painting this wall, this wall, this wall, this wall, and our ceiling. We are not painting this floor. So we're going to have to modify this surface area formula to exclude the area of this floor. And what is the area of this floor? Well, we have a width here and a length here. So the area of this floor is length times width. So here's the modification we're going to make. This is going to become surface area. Again, we're excluding the floor, which is one of these lengths times widths. This ceiling is also length times width, so we need one of those. So this is going to become length times width plus 2 width times height plus 2 height times length. All right, so that's why I unfolded that rectangular prism. So you can see that we have to exclude the floor, which we are not painting, which means we have to remove this 2 here and just leave it as length times width. All right, so with that done, let's go ahead and plug in values accordingly. We know what they all are. W is 10, L is 15, and H is 10. So W is 15, so this becomes 15 times width is 10 plus 2. Width is 10, height is 10 plus 2, height is 10, and length is 15. All right, let's go ahead and work this out. This should actually be pretty easy to do mentally. 10 times 15 is going to be 150. This is going to become 2 times 10 times 10 is 100. And 10 times 15 is going to be 150. So this is 2 times 150. Let's go ahead and keep working this out. This is 150 plus 2 times 100 is going to be 200 plus 2 times 150 is going to be 300. 150 plus 150 is 300. Let's keep working this out. This is 200 plus 300, which is 500. So this is 500 plus 150. So this is going to be 500 plus 150, which is 650. All right, so the total surface area that we're going to be painting is 650 square feet. All right, so we know that we're painting 650 square feet of wall and ceiling space. So this is going to be 650, and we're going to divide that by how many square feet each gallon of paint covers. According to the problem, each gallon of paint covers 175 square feet. So by doing 650 divided by 175, we'll know how many gallons of paint we need. And we could read this as long division like this. 650 divided by 175. And we start by asking ourselves, how many times does 175 go into 6? It doesn't. How many times does 175 go into 65? It doesn't. How many times does 175 go into 650 without going over? Well, it's going to either be 3 or 4 times. So I'm going to say it's 3, but I'm also going to work out 175 times 3 and 175 times 4, just to confirm that. 5 times 3, of course, is 15, so drop down a 5, carry a 1. 7 times 3 is 21, plus 2 is 22. Drop down a 2, carry a 2. 3 times 1 is 3, plus 2 is 5. So 3 gallons of paint covers 525 square feet. What about 4? 5 times 4 is 20, so bring down a 0, carry a 2. 7 times 4 is 28, 29, 30. Bring down a 0, carry a 3. 4 times 1 is 4, plus 3 is 7. So 4 gallons of paint covers 700 square feet of area. So clearly, if I were to do this long division here, this would be 3.7 something and so on and so forth. But it should be pretty obvious that if you get 3 gallons of paint, you're only going to be able to cover 525 square feet, which is not enough to cover our 650 square feet. So that means you're going to have to buy 4 gallons of paint, which will cover 700 square feet, and that's going to be enough to cover our 600 square feet for our walls and our ceiling. So the answer to this one is 4 gallons. All right, so number 5 says, at Home Depot, you bought 2 boxes. The first box has a square base. Each side of its base measures 10 units, and it is 4 units high. The second box is rectangular, and it has twice the volume of the square box. If the height of the second box is 5 units and its width is 10 units, what is the length of the second box? All right, so I know we're talking about boxes, And when people hear the word box, they automatically think of cubes. But in this case, we're actually working with two rectangular prisms. And more specifically, we're working with the volume of two rectangular prisms. So the volume of one of our rectangular prisms is going to be length times width times height. And the volume of our other rectangular prism is going to be length times width times height. And let's see what information we're given about these rectangular prisms. This first rectangular prism, which is over here, this is the volume of the first box, has a square base. Each side of its base measures 10 units. So the length and the width of the base of this box is going to be 10. So length and width is 10, and it is 4 units high. So h is 4. Let's go ahead and plug that in accordingly. This becomes 10 times 10 times 4. 10 times 10 is 100. 100 times 4 is 400. So the volume of this first box is 400, and it just says units. So this is units cubed. All right, so we found the volume of our first box. It has twice the volume of our second box is rectangular, and it has twice the volume of the square box. So volume 2 is going to be twice the volume of the first box. All right. Well, we can actually figure that out. What is the volume of the first box? It's right here. It's 400. So this becomes 2 times 400. 2 times 400 is 800. So the volume of our second box is going to be 800. It has a height. If the height of the second box is 5 units, so h is 5, and its width is 10 units, so w is 10. What is its length? So that's unknown. So let's go ahead and plug these things in. We know the volume of our rectangular box is going to be 800. We know its length is what we're trying to figure out. Its width is 10, and its height is 5. So clearly, we're going to be solving for L in this case, and that's actually pretty easy to do. This becomes 10 times 5, which is 50. So this is 50L equals 800. Let's divide both sides by 50 to get L by itself. This crosses out here, leaving you with just L. We can cross out these corresponding zeros, and now we're left with 80 divided by 5, which I know many of you can do in your head, but let's go ahead and work it out. 5 goes into 8 one time. 5 times 1 is 5. 8 minus 5 is 3. Drop down this 0. 5 times 6 is 30. 30 minus 30 is 0. So the length of this rectangular box is 16. And of course, that's 16 units, since we weren't given a unit of measurement. So the answer to this one is 16. All right, so number 6 says a cylinder has a volume of 502.4 centimeters cubed and a radius of 4 centimeters. What is the height of the cylinder? Use 3.14 in place of pi. All right, so we are working with a cylinder here. So if it's helpful and you can't visualize what we're doing, you can quickly make a sketch of a cylinder here. Let me draw that line a little bit better for you. More specifically, we're finding the volume of a cylinder. And you should recall my definition of volume. Volume is the area of the base times the height of the figure. Well, a cylinder has a base that's in the shape of a circle. So the area of a circle is pi r squared. And of course, I just said you multiply the area of the base times the height. So that's the formula to find the volume of a cylinder. We can label the rest of this if we want, but it's not really necessary. We know this cylinder has a radius of 4 and a height that is unknown. So we'll leave that as h. So Let's get back to the problem now that we've derived our formula just by looking at our figure. We know this cylinder has a volume of 502.4. So our V is 502.4. Our radius, or R, is 4. And we don't know what its height is. So we're ultimately going to be solving for H. So let's start plugging those things in. We're told our volume is 502.4. So in place of V, we'll go ahead and put 502.4. We were told to let pi be 3.14, so this is going to become 3.14. Our radius is right here, it's 4, so this is 4 squared, and our height's unknown, so we'll leave that as h. Let's keep working this out. This is 502.4. 4 squared is 16, so this becomes 16 times 3.14 times h. And I'm going to work this out off to the side so as not to make any mistakes there. We have 16 times 3.14. Well, as you can see, we're multiplying a whole number, notably 16, by a decimal, notably 3.14. So what you want to do is take your decimal and shift it 2 times to the right. Rewrite this as 314 times 16, albeit with no decimals. And once we do this, we're going to take the 2 decimals that we shifted to the right here, and we'll shift them to the left in our answer. So let's work this out. 6 times 4 is 24, so drop down a 4, carry a 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Let's add these together now. 4 plus 0 is 4. 8 plus 4 is 8, 9, 10, 11, 12. So bring down a 2, carry a 1. 8 plus 1 is 9, plus 1 is 10. So bring down a 0, carry a 1. 3 plus 2 is 5. Bring our 2 decimals back into the left. 1, 2. So this becomes 50.24h equals 5. My pen will let me write it. 502.4. And now we're just going to divide both sides by 50.24 to get h by itself. This crosses out here, leaving you with h on this side. And now we got to work this out. And this one should be pretty easy to do. 502.4 divided by 50.24. Well, you should know that that's going to be 10. So h in this case is 10. All right, so that is that one. I would work this out for you, but you should see 502.4 divided by 50.24 is just 10. If you multiply 50.24 by 10, you'll get 502.4. All right, so the correct answer to this one is C, 10 centimeters. All right, number 7 says, for a sphere, the volume is given by volume equals 4/3 pi r cubed, and the surface area is given by area equals 4 pi r squared. If the sphere has a surface area of 256 pi, what is the volume? All right, so we're going to start with surface area, and we know that formula, because it was given to us in the problem, is 4 pi r squared. What's more, we were told that the surface area, our SA, was 256 pi. All right, so let's go ahead and think about what we're going to have to do to solve this one. We want to know the volume of this sphere, so that's going to be volume equals 4/3 pi r cubed. What are we missing to find the volume of this sphere? Well, we're missing r. We don't know what r is. And that is the only thing that we have to plug in here to find the volume of this sphere. That said, we're going to use this information given about surface area to figure out what r is, and then ultimately we'll be able to find its volume. So again, SA is 256 pi. So in place of SA over here, I'm going to put 256 pi equals 4 pi r squared. All right, so we're going to be solving for r here, which is going to enable us to find the volume of this sphere. So let's go ahead and divide both sides by 4 pi to get r squared by itself. This crosses out here, leaving you with r squared over there. And what happens here? This pi crosses out right here. And now we can do this, 256 divided by 4. We ask ourselves, how many times does 4 go into 2? It doesn't. How many times does 4 go into 25 without going over? It's going to be 6 times. 6 times 4 is 24. 25 minus 24 is 1. Drop down this 6. How many times does 4 go into 16? Well, that's going to be 4 times. 4 times 4 is 16, so there is no remainder. So this becomes 64 equals r squared. Again, we just want r. So we're going to take the square root of both sides to get r by itself. This becomes r equals the square root of 64, which is 8. So r is 8. Now that we know r is 8, we can go ahead and plug it in here and figure out what the volume of this sphere is. So this becomes volume equals 4/3 pi, and that's going to be 8 cubed. All right, so volume equals 4/3 times pi times 8 cubed. 8 cubed is the same thing as this. It's 8 cubed is 8 times 8 times 8. 8 times 8 is 64. What is 64 times 8? So as not to make a mistake, I'm going to do that off to the side. We have 64 times 8. 4 times 8 is 32, so drop down a 2, carry a 3. 6 times 8 is 48, 49, 50, 51, so this is 512. This becomes 4/3 times pi times 512. So let's go ahead and work on simplifying this. We're going to do this off to the side. We can do 4/3 times 512 off to the side like this. And again, we can regard this like this. 4/3 times 512 over 1. You can write any whole number as a fraction by placing it over 1, which means we're going to do this. We're going to multiply straight across such that this becomes 4 times 512 over 3 times 1. 3 times 1 is just 3, so we can go ahead and work that out very quickly. Let's do 512 times 4 now. 2 times 4 is 8. 4 times 1 is 4. 5 times 4 is 20. So this is 2048 over 3. All right, so this is going to be 2048 over 3 pi. And I'm going to leave it like that. I'm not going to work this out and get you a decimal. And I'm not going to multiply by 3.14 for pi. So the answer to this one is 2048 over 3 pi. That is the volume of our sphere. All right, so that's it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. As I stressed at the beginning of this video, you really have to learn some basic formulas to answer these questions about perimeter, circles, triangles, and surface area and volume. If it's helpful, download my reference sheet and work on learning and memorizing those formulas. If you want to help my channel out, please consider subscribing to it. And on that note, I'm going to go ahead and cut you loose. Konnichiwa.